This is lesson 1B, terminology in networks and graphs. We're just going to look at a few more words that we need to know to answer networks and graphs questions. Our first word we're looking at here is walk. So a walk of length n is a succession of n edges where the end of one is the start of the next. So that just means that I'm going from node to node. I'm just counting how many edges I go, and that's the length of my walk. Like A, B, D, C. So I go from A to B, and then B to D, and then D to C. That's a walk of length 3 because I've got 1, 2, 3 edges along that walk. E, A, B, D, C. That would be a walk of length 4. So if I go from E to A, there's 1. A to B is 2. Down to D is 3, and across to C is 4 edges. That's why it's a walk of length 4. A walk in which all the nodes are different is known as a path. So a path could be from A to B, B to C, C to D, and D to F. That's a path. It's a walk where all my nodes are different. But we call it a cycle if the path starts and ends at the same vertex. So if I started at A and I went to B, C, D, E, and then back around to A, I call that a cycle. Cycles are going to be very important later on when we get to our algorithm section. A graph is connected if there's a path between any pair of vertices. A graph is disconnected if there isn't. We can see clearly here that my graph to the left is connected. I can get from one node all the way across to wherever. They're all connected to each other. Whereas on my second graph, there's a clear divide between them. So 1, 2, and 3 are joined together, but 4, 5, and 6 are not joined onto them in any way. So that's not connected. If a walk starts and ends at the same vertex, it's said to be closed. So a cycle is a closed walk. Whereas if it's not closed, we just call it open. So example of a cycle might be B, C, D, E. That's closed because it circles around onto itself. Whereas an example of an open walk would be A, B, C, D. It's not closed off, so we call it open. If two nodes are joined by an edge, they are said to be adjacent. So if there's an edge connecting two nodes, so if there's a connection between them, we call them adjacent nodes. So think about A and E and then A and C. Which of those pairs would be called adjacent? So A and E are adjacent because there's an edge connecting them. Whereas A and C are not adjacent because they're not connected by a single edge. They are connected. I could go from A to B to C, but it's not one edge connecting the two of them. So we don't call them adjacent. Just think about the word what adjacent means. It means beside. We've seen it in junior cert maths before in trigonometry. The adjacent side was always beside the angle. The handshaking lemma is a way of working out the degree total of a graph. Remember we had our degrees in our last lesson. It was just how many edges are attached to a node. If I want to find out what the total number of degrees are across a whole graph, it's just double the number of edges. Try and work out your degree total for this graph here. So my degree total here, it's going to be double my number of edges. I've got 1, 2, 3, 4, 5, 6 edges. So the degree total here would be 12. If an edge joins two nodes together, we say the two nodes are incident with the edge, or the edge is incident with the two nodes. So if it's joining two nodes together, we say it's incident. Pick out any node that's incident to this edge. So my incident nodes there would be A and E. The nodes that aren't incident then are the ones not attached to that edge, B, D, and C. Here's just a way to remember some of the vocabulary we were talking about today. So a walk, we said, was a route along all the edges. Just think of wander as you like, and walk is in there. So I can wander around anywhere I like, do whatever I want. That's a walk. A path is when no vertex or no node is repeated. So think about path is particular about the nodes. We're very particular about what nodes we choose. We don't want to choose any twice. So BACE, there's a path. And probably our most important word in this lesson is cycle. It's a closed walk which starts and ends at the same vertex. Just think cycle, circle. So if I can circle around back to where I started, that's a cycle.
If you like this video, you'll love our notes. You can get some for free in the link in the description of this video.